In this lesson, we will learn how to perform basic operations on roots. Let's begin with addition and subtraction. Here we want to add 2 root 7 and 9 root 7. Well, if we have 2 root 7s and add 9 more root 7s, then the sum will be 11 root 7s. Notice that this is no different from adding 2x and 9x to get 11x. Essentially, we can treat equivalent roots as we would treat equivalent variables. So if we take 11 times the cube root of 2 and subtract 5 times the cube root of 2, we get 6 times the cube root of 2. Finally, to simplify this expression, we must first recognize that the fifth root of 3 is the same as 1 times the fifth root of 3. So here we have 7 times the fifth root of 3 plus 2 times the fifth root of 3 minus 1 times the fifth root of 3, which equals 8 times the fifth root of 3. Now the next operation we will examine is multiplication. To multiply these two roots, we multiply the parts outside the root and multiply the parts inside the root. So here we will multiply 2 times 7 to get 14, and then we multiply 3 times 5 to get 15. For this one, we multiply 11 and 5 to get 55, and then we multiply 4 and 7 to get 28. One more example. In this case, the second term does not have a number outside the root, so it is assumed to be 1. So here we multiply 3 and 1 to get 3, and then we multiply 2 and 10 to get 20. Now the rule for division is very similar to the rule for multiplication. The rule is divide the parts outside the root and divide the parts inside the root. So first we have 21 divided by 7, which is 3, and then we have 10 divided by 2, which is 5. Now for this next expression, when we divide 3 by 6, we get 1/2. So we will place 1 on the top and 2 on the bottom. Next, when we divide 40 by 5, we get 8. Now we are not quite done yet, since we can simplify this further. In the numerator, we have the cube root of 8, and the cube root of 8 is equal to 2. When we simplify all of this, we get 1. Okay, one more example. Here, when we divide 18 by 2, we get 9, and when we divide 3 by 33, we get 1/11. So we will place the fourth root of 11 on the bottom here. Now the rules discussed in this module are sometimes misused, so it's a good idea to take a look at some common errors so we can avoid making the same mistakes. The first error is adding roots by adding the numbers inside the roots. This rule is invalid. We can show this through the following example. According to this invalid rule, the square root of 9 plus the square root of 4 should equal the square root of 9 plus 4. However, when we simplify this, we get 5 on the left-hand side and the square root of 13 on the right-hand side, and these values are not equal. In general, if two numbers, a and b, are not equal, then there is no nice way to combine the square root of a plus the square root of b. The next common error is taking the number outside the root and multiplying each term inside the root. If this were true, then 2 times the square root of 4 plus 5 would equal the square root of 2 times 4 plus 2 times 5. However, when we evaluate both sides here, we see that the left-hand side does not equal the right-hand side, so this rule is also invalid. Okay, let's summarize. In this lesson, we learned how to perform operations with roots, and we learned some common errors to avoid.